to do a quick video for you, even though I think you have this, a similar example at the beginning of the logarithm chapter. For section 5.2b in My Open Math, you are asked to graph a lot of logarithm problems, and for these you have different bases other than 10 or e. And so I wanted to show you my approach. My approach is to first graph the exponential form and then use the property of inverses. So if I was asked to graph g of x equals log base 3 of x, if that's what I'm told to graph, what I would graph first is a different problem. I would graph f of x is 3 to the x, so same base, so it's inverse. So instead, I'm going to do something totally different that it does not tell me to do in those directions. I'm going to graph 3 to the x, and I'll do that with a table. And I want to get some different values here, so I'll do -2, -1, 0, 1, and 2. That's high enough. And then I'll just plug those in. So 3 to the -2 is 1 over 3 squared, which gives you 1/9. Very tiny. 3 to the -1 is 1 over 3 to the first, which is 3. So also tiny, but a little bigger. 3 to the 0, which is 1. And when you're graphing with your tools on the My Open Math, this will be the point that you will use first with the logarithm tool. And also the exponential. We're looking at the exponential right now. So with the exponential, you'll use this point first. And then 3 to the 1 is 3, and 3 squared is 9. Now, to graph my g of x, which is the inverse of this, my base is going to be the same, and I am going to switch the x's and y's. So whatever was y becomes x. That was a 3. Looks funny. And the x's become the y's. This is what I need to put on my grid. If I'm just asked to do the log base 3 of x, which is what you're asked to do in the software. But by hand, I know that I have to do a different thing first. Now, I noticed in some of Miss Allen's videos that she used change of base instead. It's a different approach, just two different approaches. But I always tend to go with draw the exponential first and then just use the property of inverse and switch the x's and y's. So you need the table to do that. All right, let's graph them on the same grid. So first of all, if we do 3 to the x, so I have -2 and 1/9, so a little tiny bit. All right, I have -1 and 1/3, so up a little bit more. 0, 1. Sensitive tools here. 1, 3. And 2, 9, 5, 6, 7, 8, 9. So exponential looks right. A very steep graph. And remember, it's going to flip across the line y equals x. All right, so now I'm going to switch colors and do the log graph. So 1/9, so over a tiny bit and down 2. Right, a little bit more, 1/3, down 1, 1 0, 3 1, and 9 2. So this is the log graph, and this is the line y equals x that they flip across. So they are inverses. Let's see the other questions on this. The first one is, what is the domain of f of x equals 3 to the x? So the domain here, domain of f of x, this one, it goes forever to the left, it goes forever to the right as it goes up. So range of f of x, right? It has a horizontal asymptote. So on this particular problem, the lowest it's going to go, and it's not going to touch, is this y equals 0. So you're going to go from 0 to infinity, right? And then we want the domain of the log base 3 of x. So how does it act going across? This one has a vertical asymptote, and it is going to be x equals 0. You are not going to touch it, so it's going to go from 0 to infinity, right? And remember, the thing about inverses is the domain and the range switch. So whatever was the range for 3 to the x becomes the domain for its inverse.